3D organ printing is a revolutionary technology that enables the layer-by-layer creation of living tissues and organs using 3D printing, utilizing the patient's own cells. But what is the process behind this? And how did science get to this point? That's what we'll discuss in today's segment. Sci Explore Hub. The history of 3D organ printing dates back to the late 1990s when the first steps were taken towards developing additive manufacturing technology for living tissues and organs. The technology is based on the principles of traditional 3D printing but uses living cells as ink, allowing for the creation of cell structures that make up organs or tissues. Over the years, 3D organ printing has undergone significant development, resulting in several breakthroughs and success stories in the field of medical science. The first steps, in the late 1990s and early 2000s, researchers began exploring the possibilities of 3D printing in medicine, particularly in the field of tissue engineering. The goal was to develop a technology capable of printing living tissues that could potentially be used for transplantation. One of the first significant breakthroughs was achieved by the Wake Forest Institute for Regenerative Medicine, where Dr. Anthony Atala and his team presented the first 3D printed bladder in 1999, which was implanted into human patients. Organoids play a special role in 3D organ printing. These three-dimensional tissue structures produced in the laboratory mimic the characteristics of human organs and allow for modeling of the body's internal microenvironment. Organoids derived from stem cells serve various research and therapeutic purposes. With further advancements in technology, organs printed based on organoids will increasingly resemble real human organs, potentially revolutionizing transplantation medicine and disease treatment. Technological advancements in the field of 3D organ printing enable the printing of various organs and tissues for research and clinical purposes. Below, I list some examples of currently printable 3D organs and tissues. One of the most commonly printed human tissues is skin, used for treating injuries, burns, and skin replacements. 3D printed skin utilizes the patient's own cells to minimize the risk of rejection. 3D printing techniques allow for the creation of custom bone implants and structures that precisely fit the patient's specific injuries or deformities. Printing cartilage tissue, especially for joint cartilage, offers promising possibilities for the treatment of joint injuries and wear. Researchers are already able to 3D print vascular structures, which are crucial for the nourishment of more complex organs. While the complete, functional human heart remains a future goal, researchers have been able to print heart muscle tissues and heart valves, which could potentially be used in the treatment of heart diseases or repairing heart defects. As mentioned earlier, the bladder was one of the first successfully transplanted 3D printed organs, created from the patient's own cells to reduce the risk of rejection. But how are 3D organs created? Let's take a closer look at the process. The process of 3D organ printing consists of several steps, which collectively enable the creation of living tissues and organs. The first step of the process is creating a digital 3D model, which is an exact replica of the organ or tissue to be printed. This model is typically generated using imaging techniques such as MRI or CT scans, which provide detailed images of the organ or desired tissue. After creating the model, the next step is collecting the patient's cells. This is usually done through a biopsy where a small sample of cells is taken from the patient's body. These cells are then cultured in laboratory conditions to produce enough cells for printing. At this stage, a bioink is also selected, which forms the basis of the bioink. The bioink often consists of biocompatible hydrogels that support the survival and growth of cells during the printing process. Using the digital model and bioink, the next step is the actual printing. 3D bioprinters create the organ or tissue layer by layer, precisely placing the bioink and cells according to the model. After printing, organoids or organs are often incubated to allow the cells to mature and organize into tissues. This process enables the formation of connections between cells and the development of the organ's functional properties. Following this, before 3D printed organs are used in clinical applications, they undergo thorough testing to ensure their functional abilities and biocompatibility. 3D organ printing offers numerous advantages that have the potential to revolutionize transplant medicine, patient care, and drug development. Here are some key benefits that 3D printed organs can provide. 3D printed organs can be made from the patient's own cells, significantly reducing the risk of rejection and increasing the success rate of transplantation. 3D printed organs could reduce the waiting time for transplant patients, as there is no need for a donor or the lengthy donor-recipient matching process. In the long term, 3D printed organs could make transplantation procedures cheaper, especially as printing technologies continue to develop and become more economical. 3D printed tissues and organoids offer the possibility to reduce the number of animal experiments by providing human cell-based models for drug research and disease modeling. A completely new piece of news. Researchers at the University of Wisconsin-Madison have managed to print cerebellar and cortical cells, which are otherwise responsible for very different functions, but were still able to connect, communicate, and collaborate with each other. This opens up a completely new world for brain research and science. While 3D organ printing holds promising advantages, it is important to note that the technology is still under development and faces several challenges. Future developments and research will determine how these benefits become reality and to what extent they change the field of medicine. Thank you for joining us on this exciting journey, and remember, science and history always inspire us to make new discoveries. Don't forget to share your own thoughts, ideas, and theories in the comments. We're very curious to hear from you, and we'll be delighted to read them. And if you haven't already, don't hesitate to subscribe to our channel to stay updated on future exciting content and discoveries. Thank you again for your attention, and see you in the next video.